Hey, what's up, guys? This is Chung here, and today we're gonna be doing another LeetCode problem, 366, and find the leaves of binary tree. Yeah, it's a medium. I would say it's a bit like on the lower end of medium. Yeah, between easy and medium. Although it got a lot of likes, I'm gonna also give my own likes. Yeah, it's pretty classic problems here. So let's take a quick look. So it shouldn't be too hard to understand. So you're giving a binary tree, right? And and it asks you to find all the leaves, of the current tree, and you remove all leaves. Repeat until the tree is empty, right? I mean, it repeats until the tree is empty, basically, but it asks you to return this result here, right? It asks you to return this like every time once you remove this leaves, you then they're going to be 1 and a 2 here, right? So, and then the next level, the leaves will be only 2 here, right? And then 1 until the tree is empty, and then you're supposed to return this like the list of leaves for each of each level you remove each level of the current tree's leaves, right? And it says collect and remove all leaves. Repeat until the tree is empty. I mean, you I think you don't have to actually remove the leaves from the tree because all it asks you is just to return this leaves of the leaves are on each stage, right? Okay, so how can we do this, right? So I think the core concept here, or the core idea here, is the height of each node, right? I mean, if you guys know the height. So the height means the from the ground level here, from ground level goes up, right? Goes up how high this node is. So obviously height is from this ground level. So for 4 and 5, right? 4 and 5, what is the height of this tree here, right? Of this node. This is 0, right? 4 and 5. And 3 is also 0, right? Because it doesn't have any children. So that the height of the node will be the layers of the how many layers of child this current node has, right? See, 4 and 5 and 3 they don't have any child, so basically their node the height of the node is 0, and the 2 the height of 2 is 1, right? And the height of 1 is 2 because when you calculate the height, you need to consider both the left subtree and right subtree. So in this case, you get the max from both sides. So in this case, the right side is 1, the left side is 2. So the height of node 1 is going to be 2. So since you already see this, right? See, we already saw this of this height here. We can easily find out, right? For height zeros, for all the nodes with height zeros will be the result in the first element of the array, right? And all the nodes with height 1 will be the second element in the final result. And so same for the 1, right? So the height 2 will be the last one in the result. And then now this problem turns will become to how can we calculate the height of the tree, right? Okay, so how do we do a height, right? Uh, how can we calculate the height? We're gonna need a recursive function here. So we're gonna define get height with the current node, right? So we're gonna write some the core piece, right? The height will be what, like what we discussed, gonna be the max of the left side, right? Gonna be the max of the left subtree and the right subtree, right? So in this case, gonna be node. Uh, so we're gonna call this recursively, right? Get height node dot left, right? And then the height of the right subtree will be node dot right, right? And then in the end, we need to plus one, right? Because with current node, we always need to plus one. Otherwise, the height will never increase, right? So since we have that one, and we need to like check the base case, right? So if not known, right? If the node is known, if we reach the bottom of the tree, we just return minus one here, right? Because like what we discussed. So for 4 and 5, we're defining 4 and 5. The leaf node, they will have the height equals to 0, right? So in this case, let's assume this node is 4, right? It's 4. So the left is none, right? The left is none, and the right is also none, right? So when we reach here, we're gonna return a value here. So and then we're gonna do a max from them. So since we return minus one, so the max of left and right will be minus one. Minus one plus one will be 0. That's the height we need, right? And since we already have the height here, right? So every time we have a height for the current node, we can just simply add it to our final result, right? So here, basically, this is gonna be we just write get height for the current row. That's root, right? And in the end, we just return the result here, right? Ideally, what we can do here, we should be able to we should just return uh, the result what the index, so the height will be our index, right? And then we can just simply append it, right? We're, we're hoping we can just append, right? So that's our ideal case. But before append to this list, we have to initialize this list, right? Otherwise, you will get like a index exception, right? Because we don't have the list in this result yet. So what do we do here? A trick here will be, we could use a dictionary. I mean, every time we just use a dictionary, but in the end, we have to sort the dictionary by the key, right? And then output that the list, the value of the key. So what we can do here, we can do a quick check here, right? Height, if the height is greater or equal than the length of the current result, right? Actually, we can do either like a greater or equal, or we can just do the equal here. I think it's the same. Yeah. Okay, I'll do a greater or equal here. So every time when it's at the same or greater than the length of result, what do we do? We just simply append, right? We just simply append an empty list to this result, right? And then we're sure that when we try to append our node result to this result list, there will be a list there, right? Yeah, I think that's it, right? So pretty straightforward. Let's run it. Uh, if Yeah, what a stupid mistake here. Append. So many typos. Result. Get height. Value. Yes. And yeah, in the end, yeah, we also need to return the height. Yeah, because we're doing this recursive call. So each get height method should have a height return, so we can use it for the later calculation. Yeah, cool. See. So it passes it. Okay, it's pretty straightforward. Basically, we just need to calculate each node's height, right? Yeah, basically here, what see we are so this final result here is going to be the height of the root, right? So this is going to be the height of root, right? In the end, we'll get a height of root here, but we don't care, right? So maybe in some other problems we need this return value here because we're getting a root of this thing here. So what we need is that during the process of getting the height of the root, we will be getting all the heights for all the subnodes, right? That's what we need because we need each node's height to determine where this node should be in the final result, right? So in this case, we're not removing this, we're not removing any nodes. Yeah, because all we need is their height, right? So we get their height, and with their height, we know what position that node should be in the final result. And the final result list, the height basically will be their index, right? And then in the end, we just return. Uh, cool. I think that's it for today. All right. Thanks for watching. Yep. Bye.